Hi, thank you for joining us at Automation Fair 2020 today. I'm Doug Weber, Business Manager for the Networks business at Rockwell Automation, and I'm joined today by Scott Friberg from our partner Cisco. I'll let Scott introduce himself.
Yes, I'm Scott Friberg. Worked with Rockwell for 10 years, covering the alliance and technical functions.
Thanks, Scott. We're here today to talk about some collaboration that Rockwell Automation and Cisco have undertaken to better integrate our two ecosystems with the goal of helping our customers reduce risk and decrease complexity in managing their OT networks. Collaboration includes integration between tools available to OT practitioners and tools commonly used by IT practitioners to manage security and other policies in their IT networks. Here's the agenda for today's presentation. First, we'll review the state of plant-wide and site-wide cybersecurity. And then second, we'll address some key challenges that industrial customers face in trying to respond to some of today's cybersecurity challenges. Third, Scott will review our joint Converged Plantwide Ethernet cybersecurity framework. And then we'll get to the meat of the presentation, which covers how we can apply some of these IT concepts to the OT environment. And we'll finish up with key takeaways. So manufacturers today are seeing significant growth in demand as more and more people around the world become consumers. At the same time they're seeing these increases in demand, they face issues that have the potential to impact their productivity and profitability. A few of those issues include what's shown on this slide. 87% of manufacturing executives report that aging infrastructure impacts their operations. And 28% of manufacturing organizations report a loss of revenue due to security incidents in the last year. 3.2 billion new industrial IoT devices coming online by this year is another issue that manufacturers face. The net result of this is that manufacturers need to modernize their operations, and with that, their network infrastructure through digital transformation. To highlight those security challenges, cyber criminals are becoming more and more successful at infiltrating and attacking industrial customers. Whether companies are paying or not, these attacks are having a significant financial impact on manufacturers. In the last 2 years, 53% of manufacturers have experienced a cybersecurity breach in their facility, amounting to more than $11.7 billion in damages due to ransomware attacks. The threat actors and types of attacks that pose a risk to manufacturers are varied, and we have examples of attacks that have emanated from nation states, from insiders, from terrorists, from hacktivists, and even cyber criminals. And while we hear most often in the news about nation states and cybersecurities, we should highlight here the risk posed by insiders. We need to consider that while there are cases where disgruntled employees have undertaken actions to intentionally harm their employers, more often we find that an employee has done something inadvertently that compromised security. For example, an employee may access a critical asset and make changes to that asset, like a change to a control program, thinking they are actually making a change in a different part of the plant. So that's a quick overview of the kinds of threats manufacturers face today. At this point, we're going to pivot and walk through some of the challenges that our customers tell us they have as they try to address these OT security threats. These challenges are related to the management of their OT networks and to the collaboration that needs to occur between OT and IT within their organizations. We'll finish this section by introducing the concept of software-defined security, which we believe is one of the key IT concepts that we can apply to our OT environment. So here are the most common challenges we hear our customers say they need to overcome in order to improve the cybersecurity posture of their manufacturing plants. I'd like to highlight just a couple in particular. The first challenge that many customers mention is the lack of visibility into what's out there on their industrial networks. In the IT space, visibility to what is connected is typically really good. But in OT networks, devices tend to get added or removed based on the needs of production. And since you can't secure what you can't see, often the first challenge is understanding what is connected. The second challenge I want to highlight is insecure design and lack of segmentation. Many customers by this point have done a good job of securing the connection between their enterprise or IT systems and their plant for OT networks. This separation is an effort to make sure that any breach in their IT space is isolated from the OT system and doesn't give an attacker access to their manufacturing network. That separation usually consists of some type of IDMZ that is set up between the IT and OT networks. What a lot of customers lack, however, is segmentation at the OT level. In other words, if a bad actor were to get into the OT network, they might have access to the full breadth of the network. So one of the things that Rockwell Automation and Cisco have collaborated together on are a series of reference designs and reference architectures to help educate OT practitioners about how to design their networks with more segmentation. So if a bad actor were to get into the network, the number of assets they have access to will be limited and bounded due to the segmentation they've implemented. Scott will come back to this in a little bit to talk more about segmentation. In addition to the points on the previous slides, as customers attempt to move to a more connected enterprise, their network becomes more complex and new challenges appear. Most of these challenges boil down to some of the special requirements of OT networks or to the lack of integrated processes between OT and IT. Those challenges include an increasing number of IIoT endpoint types in the OT space, which make it challenging to segment and scale. Also, issue resolution is slowed down due to the fact that IT and OT operate under different policies, and escalation of issues have to cross these functional boundaries. Finally, OT networks are typically configured and managed at a switch-by-switch basis, not driven from a network policy standpoint. And all of these challenges require closer collaboration between OT and IT. One of the technologies that has become very popular in the IT world is this concept of software-defined capabilities. If you think about software-defined in the context of OT systems, we have some good examples of how technologies that nearly all OT folks are familiar with have migrated over time into a software-defined paradigm. So what you see on the left side of the slide are two very significant shifts that have occurred, from hardwired to software-defined systems. For example, many years ago, our machines and processes were controlled with relay logic. In the 1970s, we started replacing those cabinets full of relays with PLCs, where we defined control functionality by writing software programs. It was a much more flexible and more easily modified way to control machines and processes. The second example you see on the left side is the migration from hardwired physical push buttons and indicators to HMI panels with integrated control functions. So while we didn't call it software-defined, it's a very similar concept to what's happened on the IT side. With that, I'm going to turn it over to Scott, and he'll explain what software-defined means in the context of IT systems.
Hey, folks. So the easiest way that I know to explain what software-defined anything is, if you start with networking, it's taking some of the intelligence out of the end devices, the networking devices, and putting it into a computer. And that computer has the ability to make changes to all of those end devices. We kind of first started seeing that with networking, but it's taken a life of its own. And now there's multiple things that we use software-defined capabilities with. Today, we're going to talk about security. The main problem with security, Doug mentioned a lot of reasons why we need it, but the main thing that's difficult with security is that it's really complex and it's hard to monitor, change, make configuration changes. I'll explain why in just a second. But that's what software-defined anything is. I'm going to build this out. So the way that we do segmentation, and Doug explained why that's so important, is we use end devices and things called access control lists. What an access control list does is it maps an IP address to an end device and whether that end device is allowed to talk to another IP address. So typically you'll see, whether somebody has access to one of the devices on the plant floor. That's what we're talking about with this. When I think about CPWE, segmentation is the absolute number one thing that we stress. The reason why it's important is if one device gets affected in a certain zone, it's going to affect every other device in that zone. And if your zones are large, that means more devices are going to get hit. So it's extremely important when you're setting up your security policies that you think about segmentation. Couple of slides on Cisco and Rockwell's sort of vision for security. We are both the leaders in our different fields, and we have been collaborating for over 12 years on not only networking hardware, but CPWE as well. Converged Plantwide Ethernet is a common architecture that follows the Cisco validated design program. Part of that program is the testing of the different use cases that we come up with. We always start with use cases that define a business case, and try to fix those business cases within the network topologies that we're using. And the solution that we're going to talk about today deals with 3 different use cases related to security of OT networks. Converged Plantwide Ethernet has been around for more than 10 years. It's a program that continues to grow. We started out with a general networking design. So we started out with the general network, and then from there we add on, and it gets bigger and bigger. So we added wireless. We've added a data center component. We have added PRP and PTP. Within each one of those, we have to consider security. Wireless has its own security challenges. Specific networking has its own, security challenges. So within each different version, we have a security lens that looks at, all the different things that we do. The goals for CPWE are listed at the bottom. Enable business agility, which means you can adapt the network to grow and scale. Optimize production yield. That's what we're in business for. We're in business to make things. And if the network is down or the lines are down, we're not making things and we're losing money. And then minimize risk. That is all about security. We have seen attack after attack bring down networks, loss of millions and millions of dollars because things aren't secure. It used to be, 5 or 6 years ago, manufacturers could get away with that because their networks were separated from the IT side. But as people, look at the OT networks and the lack of security, they have built their own, tools that attack the OT networks themselves. So that's the third thing that we focus on with CPWE. Gosh, I guess one more thing I would mention. We not only focus on the plant floor, we focus all the way to the cloud. So sensor all the way to the cloud, we think of everything in between there. I can't remember how far, this build. So it's a very complex slide. You can look at it when you download the presentation, but we call this the industrial security framework. And it's basically a list of where the different security functions fall to either the IT engineer or the OT engineer. Certain parts of the network are only going to be touched by the IT guys. Vice versa, certain parts of the network are only ever going to be touched by the OT guys. There are different policies that are used in IT to protect, back-end data center systems. Whereas with the OT side, you're basically protecting the lines from going down. You want packets to be going all the time. So that's, those are the things that we focus on. And back to Doug.
Thank you, Scott. Up to this point, we've walked through the nature of the threats that exist in manufacturing environments, and we've discussed some of the common challenges our customers tell us they have in addressing those threats as they build their connected enterprise and start to bring their IT and OT networks together. Finally, Scott reviewed some of the joint work Rockwell Automation and Cisco have done and the joint materials we've created to help customers on their journey. These materials include reference architectures and design and implementation guides that customers can use as a basis for good network designs in their manufacturing facilities. Now we'd like to talk in more depth about the joint solutions Rockwell Automation and Cisco have to better integrate and manage their IT and OT networks. So I'll go through a couple of high-level slides to lay out the concepts involved, talk about one of the products that Rockwell Automation has to help facilitate the collaboration, and then I'll turn it back over to Scott to go into more detail about how these solutions work together, what some of the benefits are, and how to improve the security of your OT network. On the left side of this slide, you see traditional OT assets, including devices like automation controllers, HMI, variable frequency drives, and I/O. And on the right side, you see some of the traditional IT tools and systems that are used to secure and manage IT networks. What Cisco and Rockwell Automation have done via the FactoryTalk Network Manager product is to create a mechanism to connect and integrate these two environments. So one of the big challenges that companies have in trying to apply their IT policies and tools in the OT space is their inability to get real-time information about and from those OT assets, and to get that information into their IT infrastructure where most of the corporate security policies are deployed and enforced. So via FactoryTalk Network Manager, we've created a way to capture information about the OT assets, and through this integration technology called PX Grid, to expose that context to the broader Cisco ecosystem. In this picture, we show that as a connection to a Cisco platform called ISE or ICE. So again, one of the pieces of information we gather with FactoryTalk Network Manager is the identity or the context of devices in the OT environment. In the IT environment, most devices that get plugged into a network identify themselves. So for example, if you plug in a voice over IP phone into an IT network, the phone identifies itself as a VoIP phone. The self-identification of devices on the network is one of the reasons that Cisco has been able to make such extensive progress in the IT space to automate the management of the enterprise network. And so in the enterprise network, policies can be written that say, hey, if you see a VoIP phone appear on the network, here are the things I want you to do relative to the configuration of the network to ensure that the phone works properly, but just as importantly, that it's secured. This has traditionally been a problem with OT assets. In the OT network, not many devices will identify themselves, or certainly will identify themselves in a way that an IT system can understand what they are. And so one of the things that Cisco and Rockwell Automation have been able to do by working together is to not only tell the IT systems a device exists on the OT network, but to provide additional context about what that device is. That context is important if we want IT tools to be useful in managing and securing our OT network. So that's the first piece of information that FactoryTalk Network Manager can provide, is the visibility into what devices are on the network. So visibility is an important step, but that's not everything that IT needs to know in order to write and enforce security policies in the OT network. In the example we used earlier, the IT folks will automatically know what a voice over IP phone is and what policies to assign to it. However, what they won't know is in what context a device is being added to an OT application. If an HMI or a variable frequency drive is added to an OT network, IT doesn't know what function that device is meant to perform in the plant. And IT won't know what the implication is that that device is compromised. For example, you could think about a VFD that appears on the OT network. The VFD might be running an outfeed conveyor that would have minimal impact on production if it were compromised. On the other hand, it might be running a ventilation or an exhaust fan. And if that fan fails to operate correctly, it could put employees' lives in danger. So these OT devices and their applications are not something IT is familiar with or will understand. And so the second step that Rockwell Automation and Cisco took to provide a graphical interface in FactoryTalk Network Manager that allows OT to scan the network, find the OT devices, and then group those devices into security group tags, or SGTs, according to how they're deployed in the plant. Once those devices have been grouped by OT in a way that makes sense, that information is shared with IT, so they can apply policies to the group of devices and the associated network infrastructure, instead of having to write policies around each specific device. So I just want to take a short minute here to talk a little bit more about FactoryTalk Network Manager software. there are really three key benefits to highlight about FactoryTalk Network Manager, and they fall under these three categories listed across the bottom of the slide. The first, and we've talked about this a little bit, is network visibility. So that includes discovery of Plant 4 assets with multiple discovery protocols, the topology and device view that you see in the slide here. It includes the ability to bridge through the controller backplane to see devices on the other side of the controller. And then finally, Scott mentioned earlier, VLAN, PTP, there's other information that we can overlay on top of this network diagram to give you additional visibility into the network, into the OT network operation. In the middle, you see troubleshooting. So that includes the ability to capture alarms and events on the network. It includes the historical retention and logging so that analysis and resolution can happen after the fact, and even email notifications. So we can use events and alarms on the network to drive email notifications. And then finally, it is also a tool that allows you to do configuration and maintenance of switches. So you can configure switch ports from Network Manager. You can back up switch configuration. You can compare and restore switch configuration. And finally, you can do switch firmware upgrades through FactoryTalk Network Manager. So again, it's a tool that does a lot of things around managing the devices and having visibility into the OT network.
I just wanted to make one comment on this slide. One of the things that I think is one of the coolest aspects of FactoryTalk Network Manager is this topology map that it draws. It makes it very easy to see things on a topology map that you may not know that are there. OT networks traditionally have used unmanaged switches, and unmanaged switches have a tendency to hide things sometimes. So this map that FactoryTalk Network Manager is able to draw is extremely helpful for someone that is trying to troubleshoot different parts of the network if they don't know that they're there. So I just wanted to mention that. That didn't advance. There we go. I mentioned earlier that we always start with use cases, and I'm going to walk through 3 of the use cases that we've come up with related to security. Like I mentioned earlier, with CPWE, segmentation is always the first thing that we look at. When Doug was explaining FactoryTalk Network Manager, he mentioned a Cisco product called Identity Services Engine. Identity Services Engine is also known as ICE, and what it is a software-defined policy piece of software that can manage all of the different network devices on the network. So it is switches, it's wireless, different firewalls. It can push configuration down to those devices automatically to segment, different parts of the network. Maybe you want someone that, a guest that comes in and you want to enable them access to the internet, but you don't want to, give them access to certain other parts of the network that are, that are important, especially on the OT side. Sorry, Doug, I almost called you Gregory. Doug mentioned the aspect of software group tags. That's a key part of the way that ICE is able to do things and make things less complicated. Traditionally, what we've used is access control lists. I mentioned that earlier. Access control lists are all done by IP address and by port number. What ICE uses is something called a security group tag. And what that does, when you configure ICE, you put all of the different devices on the network into a security group, and that's given a tag. Cisco devices can read that tag and can block or allow different traffic to go from a device in one tag group to a device in the other group. That might be cell area zones, it might be OEM machines, it might be parts of the industrial data center that you want people to have access to. It sets all of that up, and the nice thing about ICE is it's typically difficult for humans to remember numbers, like lots of numbers. I reached a point where I had enough contacts, with my phone that I had to stop relying on my ability to memorize their phone numbers. And I just put everyone in, with names. I'm sure everybody does that, right? But security group tags are a very similar thing. It's easier for somebody to look at an asset and know that it's in group 100 than to remember its IP address and what other IP addresses that device is actually able to talk to. So on the left, this is what I was talking about legacy-wise. Static ACLs, the person that is managing the security policy has to go in manually and change the access control list on any device that they're trying to enforce that policy on. And it is very, very easy to make a mistake when you're doing that. That's why we use ICE. And the thing about ICE that's becoming more and more important is the complexity of the OT networks is starting to get a lot worse. As we add different technologies to the network, it gets more difficult to manage the security policy across that network. And that's primarily why we have ICE. What ICE can do is automatically configure an end device like a switch with an access control list. The person that's managing that policy doesn't have to make any change to the actual configuration on the switch itself. Very powerful. I mentioned earlier the security group tags. If you look on the bottom left of the screen, you'll see the different groups and the way that we have those set up. So if you see a yellow Y, that means security group on the left, let's say number 10, is allowed to talk to security group 100. However, security group 10 is not allowed to talk to security group 20. So any of the devices that are in security group 10 don't have access to anything that's in security group 20. And like I mentioned earlier, you can separate things like Ceiliarea zones, you can separate users, you can separate servers, different applications on the servers because they're using certain port numbers. You can allow people automatic access to the internet. You just make a change to the user profile and put them in a different security group tag, and give them access to certain things or block them. Gosh, let me before I go on, ICE is a tremendous IT resource at this point. It automatically knows all different versions of Windows, all different versions of iPhones. If you plug an iPhone in to a wireless network that's using ICE, it automatically knows what that is. The problem is it wasn't designed for an OT network, and so it has no visibility at all into what a PLC from Rockwell is, any drives, any I/O. It needs to be fed that information, and that's what FactoryTalk Network Manager gives it. PX Grid it's just an API. It's a way for two computers to talk to each other. Doug mentioned that earlier, and PX Grid is the channel that allows FactoryTalk Network Manager to feed information to Identity Services Engine or ICE. So this is our second use case that we came up with related to security and the use of ICE and another product called Stealthwatch, which I'll get into. There's a lot of demand for remote access, and remote access is very tricky because you typically don't want anyone from the outside to, have access to any of the devices on the plant floor. However, if you have an OEM that's from Germany and it's on a machine in the States, it costs a lot of money, obviously, to fly someone over here. So there is a strong use case for remote access. What we can do with FactoryTalk Network Manager is change the tag within FactoryTalk Network Manager, and it automatically goes over and changes that in ICE. So, for example, on your firewall in the IDMZ, you might want to allow a certain person who's in a group tag, who might be out on the internet somewhere, to access a machine that's down on the plant floor. And what the OT engineer would do is change the tag that the machine is in, and it automatically allows that person access to the machine for however much time you want it to have. If it's an hour, it'll automatically change back after an hour. You could also give it to them for a day, or you could make it permanent. The nice thing is when you make that change with FactoryTalk Network Manager, it automatically goes to ICE, and the two of them are working together. It's really the only way that we can do these kinds of things on the OT network, because we just don't have the visibility with ICE. So our third use case for network security uses a product called Stealthwatch. What we were trying to do is to figure out network flows that are different than what is normally seen with the network. And we call it anomaly detection. What Stealthwatch does is you turn it on, and it monitors the network for however many weeks and figures out what all of the traffic should be on a base level. And it just sits there monitoring what these network flows are. So say PLC A is talking to drive number 16. It knows after, Stealthwatch sits there and watches that traffic, that is normal traffic. And, it's allowed by the security policy and by Stealthwatch. Well, what happens if one day PLC2 tries to initiate a traffic out to the internet, which typically we see with malware. When something is affected with malware, it will typically try to go talk to something that's out in the internet and get more instructions. Stealthwatch will see that traffic from PLC2 and will say, that's not allowed. It can send email alerts. It can send text alerts. It can even work with ICE to block that device, from, having that traffic flow. We use it, widely within the IT side, but it's only because we have FactoryTalk Network Manager that's able to deliver, the visibility and the identity of the OT assets, that we can do that with Stealthwatch on the OT side. So like I said, Stealthwatch, it's an application. It just looks at network flows. It's pretty old technology called NetFlow. And what engineers have typically used NetFlow for is to monitor bandwidth usage. And so they look at flows across routers and switches, and they're able to see if they have an efficient use of the network devices and where the traffic is going and that kind of thing. Well, at some point somebody said, well, from a security standpoint, we can really use that information. And so Cisco acquired a company called Landcope about 6 or 7 years ago and turned the product that they had into something called Stealthwatch. So it, like I said, it watches the flows. If it sees something that is not normal, it can detect that. Then it can decide whether it's a threat or not, and then it can do something about that. We can put it, put that device into a VLAN that is basically not allowed to talk to anything else. Sometimes that could be a problem. So it just depends on the security policy and the risk that you are willing to have within the network based on security. But it can do all of those things automatically. You'd have to have a team of people, that are looking at, the different network flows, and be able to figure out if something has gone wrong. Imagine, a computer or an application like Stealthwatch just sitting there doing that automatically for several weeks. How many man hours of, someone's time that would take? So it's just another use of software-defined technology that we have within Cisco. All right, CPWE network security, that's what we're talking about. CPWE has about 18 versions at this point. Like I mentioned before, dealing with all kinds of different architectures and technologies that we use in IT and in OT. But this particular CVD is strictly focused on security. And the basis of this CVD or CPWE version is to answer the business cases related to software-defined segmentation, software-defined remote access, and anomaly detection and threat detection. What we do with any of the different versions of CPWE is we decide what we want to try to solve, and then we figure out what the network topology is going to look like. After that, we have labs. Rockwell has a lab in Mayfield Heights in Ohio. Cisco has a lab in RTP, Research Triangle Park in North Carolina. The two of us set up the lab topologies to basically simulate packets going through that network to see if what we're trying to solve is possible, and not only that, but the best way to do it. And so the output of that testing is this CVD, CPWE network security. It's been out about 2 years. All right, key takeaways. This is a slide that we came up with that basically tries to compare the legacy way that we've done segmentation versus the way that we do it within software using ICE. The cost of the implementation, the cost of the configuration, the cost of monitoring all go down because it's done automatically, and your risk goes down as well because the computer, as long as it's configured correctly, is going to do the same thing every single time. So ICE will change the security group tag from one to the other automatically. It automatically downloads the access control list to the end devices, whether it's a firewall, a wireless access point, or the switches themselves. When you do that with a group of people, depending on the complexity of the network, it can be very expensive, and it's very easy to make mistakes. You can bring down a whole network by one line of an access control list. Great. All right. Gosh, a couple of things that I would hit on here, and Doug, I'll let you, I'll let you speak to a few as well. But the Stratix joint product that we have, which is a managed network switch, is integral to this solution. Security group tags can be passed through specific network devices if they run a certain software and a certain ASIC. The Stratix 5400 and the 5410 both have the ability to pass security group tags through the switch automatically. Other devices don't have that ability. You can get around that using a protocol called SXP, but it is a lot more efficient if you can actually do it on the network device itself. I'd also say Converged Plantwide Ethernet, the program, the testing, it's a difficult thing to do. It's hard. We don't look at wins, we look at losses, we look at ways of fixing things. And we don't look at success as success, we look at success as fixing failures. it's a stringent program, and it really, the only reason why we do it is to help customers understand how to configure the devices on their network to solve the basic business problems that we, put forward. Doug, I don't know if you have anything you want to draw out of there.
Yeah, the only thing I would also add is just that, certainly within Rockwell, in addition to all the work that we do with Cisco around Converged Plantwide Ethernet, we do have a group within our services business that provides network and security services. So they are very well versed in these architectures and in, many of these products, both hardware and software products that we're talking about. So certainly that is a way if you need help to implement something. Certainly, the Rockwell Automation Service Organization has a lot of services to help you. I think there's a couple of slides in here, Scott, if you want to forward it, that just some additional information. This is a list of other Automation Fair sessions that you may be interested in. And the one that you're in right now is this PT27. But there are several others that might interest you around Ethernet IP, around network topologies, cybersecurity. So please take a look at some of these other sessions. And then finally, Scott, if you want to talk to the next slide about the new CPWE experience tool, just a reminder for customers.
Yeah, so this is another piece of joint work. We realized at some point that we didn't have a good marketing focused way of viewing CPWE, and this tool has only been live for I think 3 weeks, maybe a month, but it's interactive. It touches on all the different versions of CPWE. It addresses a field setting, which would be more like an oil and gas utility plant, and also a manufacturing plant, like a discrete manufacturing floor. It's interactive, so once you click on a certain problem, it takes you to where the resources are within CPWE that can solve those, like what we were talking about today. And you can see the middle, I don't know if you can see my cursor, but you probably can. The middle slide there, you can actually see what the slide of the plant floor looks like. And each one of those little red circles is a business use case that we're trying to solve with the different topologies, that we put forth in the program. So it's listed down there at the link. We're really proud of it. We're really happy with the way that it's turned out. Feel like it's very interactive, and we'll be able to help a lot of people understand CPWE in a way that is not quite as complex as some of the material that we've had in the past. So really thumbs up on this one. Really, really happy with it.
Thanks, Scott. I think that's it for today. Thanks for joining us.
Yeah, thanks very, very much for the time.